So moving on to question 4, part B of winter 17, paper 1, variant 1. So the question says the following table shows part of the instruction set for a processor. The processor has one general purpose register, the accumulator, and an index register. So this table is pretty standard. So this has instruction and the explanation for each of the instructions. You must have seen these opcodes before when you are solving different questions. So what I'm going to do is I'm going to solve the question and then refer this table again and again so you can see what's happening in for each opcode. So the question says complete the trace table for the following assembly language program. So these are the instructions, these are the labels. So this is basically symbolic addressing. So assembly language program written using symbolic addressing. This is the trace table that we are going to fill, and ASCII code table that we'll use in this question. So the first instruction is LDV hash countdown. So if you do not remember what LDV is, you just go back. LDV hash n. This is relative addressing. Move to the address and locations from the address of the current instruction. Load the contents of this address to the accumulator. So countdown is for now 15. So what you need to do is you need to just move 15 blocks down from where you were. So this is going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, and 16. So if you move 15 steps down, you will see that we have received the value 67. So we're going to load this value. So this has already been loaded in the accumulator. Moving to the second instruction, this is CMP. CMP is compare the contents of the accumulator with the number n. So number is num1. The value for num1 is 32. If you compare this value 67 with 32, the result can either be equal to or not equal to. Currently the value result is not equal to. Okay. J and E carry on. J and E is basically jump if not equal. J and E following a compare instruction, jump to address if the compare was false. The compare was false because it was not equal. So we'll jump from this instruction to carry on label. So carry on label is over here. We have reached there. This says out ch. Out ch is basically output. Output the character corresponding to the ASCII character code in accumulator. So current value in the accumulator is 67. 67 in this ASCII table is B. So sorry, this is C, and the output is C. Then the next instruction is LDD countdown. LDD is load direct addressing. Load the contents of the given address to the accumulator. The address is countdown. So countdown is 15. Okay. So we move to countdown. The value is 15. So we loaded this value in the accumulator. We have received 15 in the accumulator. Okay, moving on. Okay, decrement. DEC is decrement, -1 from the value in the accumulator and then store it again in the accumulator. So this becomes 14. 15 minus 1 is 14. STO countdown. So store the value you have in the accumulator. STO means store the contents of the accumulator at the given address. So the address given is countdown. So you store the value which is currently in the accumulator in countdown. So we have a separate column for countdown. We store this value here. What you can do is you can use the same row as long as there are values in different columns. If you have to use or write a value in the same column or a column which has already been filled, you use a different row. the next row. Okay, so we stored JMP. JMP is jump without comparison. You don't have to check anything. Unconditionally jump to the given address. So the address given here is, so this is start program. So we jumped to this label. This is again LDV countdown. The current value for countdown is 14. We jump 14 steps down. We get the value 51. We load this value into the accumulator. Compared with number 1, number 1 is still 32. We compare with 51. The value in the accumulator we get again not equal to. Okay. Then JNE still jump if not equal to carry on. We jump to carry on out CH. The current value for accumulator is 51. In accumulator, in ASCII table, 51 is 3. So we output the value 3. Next instruction is LDD countdown. Load the value which is in the countdown. This becomes 14. Then decrement the value DEC. So -1, this becomes 13. Then you store the value in the countdown again. So this value 13 is stored in the countdown column. Then you jump to the start of the program again, unconditionally. You jump here. So LDV hash countdown. The current value for countdown is 13. You go 13 steps down. So this is 32. You load this value 32 into the accumulator. 32. Then you compare with num1. So num1 is 32. So 32 and 32 will be same, and this is equal to. So JNE will not work here because the previous comparison was equal, not equal. So then we move to this. So instead of this, we move to the next instruction. This is JMP. JMP, you remember, was unconditional jump to finish. So this label over here. So this is LDM hash 88. So this is load the value 88. If you don't remember that, immediate addressing, load the number n to the accumulator. So load this value in the accumulator 88. Then out ch, the value in accumulator is 88. The ASCII code of 88 is x. You output this value x. The next instruction is end. So end means you end the program over there. So we do not have any instruction and explanation for end. This is very standard. You just end the program and your question there.